Hello, this is Dr. Yamada. In this video, I'm going to explain the concept of an independent t-test. In this level 1 video, I'm going to only discuss the conceptual understanding of an independent t-test. Therefore, I'm not going to go through the mathematical processes, which will be explained in level 2. What is an independent t-test? So, independent t-test is an inferential statistics that evaluates a statistical significance between two independent groups. When do you use it? When your research question is to compare two groups or interventions. So, some of the example research questions would be: is there any differences between two interventions? Or is intervention A better than intervention B? Or is this new emerging technology better than the traditional technology? Those are examples when using an independent t-test would be appropriate. So when can you use it? Is first, you don't have access to the population mean or standard deviation. So because it is an inferential statistics, right? So you recruit participants from the population and then you use the sample to estimate the population mean. And you want to compare only two groups. And the data must be independent, which I will explain. And the independent variable must be categorical, and the dependent variable must be continuous. And you have to meet the normality of assumptions and the homogeneity of variance. What does it mean by independent? So data or groups are called independent when you recruit participants, and those participants are allocated into one of the two groups. Okay, and then participants in one group will never experience the treatment of the other group. If your research design is like this is called a between subject design. Next, the independent variable, the variable that you manipulate, must be categorical. So, for example, groups or interventions, right, on the age group, younger adults versus older adults, or you arbitrarily define. So the variable you manipulate must be category. And the dependent variable, which is what you measure, must be continuous. Like the variable numbers that can take any values, like heart rate, body weight, blood pressure, reaction time, speed, exam scores, the number of pull ups you can do, performance, accuracy or error measurement, those are examples of continuous variables. I explain the normality of assumptions and the homogeneity of variance in a separate video, but just quickly, so when data are normally distributed, the location of mean, median, and mode are identical, theoretically identical or very similar. So that means the data are symmetrical and not skewed. And also, the data should be unimodal. There's only one peak in the data. And also, data is not too spread apart or too clustered in one location, meaning that most scores are located around the mean and there are small portion of people who score lower and higher, extremely lower and extremely higher, creating a bell-shaped curve, and there's no outliers. So that's the definition of normality. And for independent t-test, additional rule you have to meet to use the test is the variance, the scatterness of the distribution between the groups are similar. So for the statistical procedure of the independent t-test, first you have to establish the null hypothesis and the alternative hypothesis. The null hypothesis predicts there is no difference. Therefore, the mean difference between group is zero. And the alternative hypothesis would be basically it is your research hypothesis, and therefore you predict there is difference. Right? There are two approaches you can establish the alternative hypothesis. One way is called the two-tailed hypothesis, where you predict there will be difference. However, you don't specifically predict group 1 is better or worse than the other. So, specifically predicting which one is better or worse is known as one-tailed hypothesis, aka the directional hypothesis. You can construct either alternative hypothesis, not both. After you establish the null hypothesis and the alternative hypothesis, the next step is to determine an alpha level. And this establishes the critical value and the critical region with the degrees of freedom. And the degrees of freedom for the independent t-test is n minus 2. So the n is a capital N, therefore the total sample size. If you have 40 people and 20 people are allocated into group 1 and the other 20 people are allocated in group 2, the capital N will be 20 plus 20, 40. So in this example, 40 minus 2 and 38. After the statistical analysis, what you obtain will be t-score and the p-value. So if the p-value is less than the alpha level, for example, p less than 0.05, then it means statistically significant. If the test is statistically significant, you can reject the null hypothesis, meaning you support your research hypothesis or the alternative hypothesis. So you conclude that there is a group difference. In the background, when you set up an alpha, then the software or you can determine the critical value. So the critical value or alpha is like a borderline that you have to meet. If the t-score is greater than or exceeded the critical value, then you reject the null hypothesis or you determine it is significant. It is statistically significant. And you can say the same thing is p-value is less than alpha. So when the t-score exceeded the critical value, the p-value is always less than the alpha level. So the relationship between t-score and the critical value is the same as the relationship between p-value and the alpha level. The t-score and the critical value is just a standardized value. And if you translate those values into probability, that would be the p-value and alpha level. Okay, after you obtain the results, how you can write up the results? So there are different variations, but mainly you have to describe in a sentence whether there was a significant difference or not, and you want to add descriptive statistics, which is the mean and standard deviation of each group, and the inferential statistics results. 3 pieces of information. Most important is t-score, degrees of freedom, and p-value. So after you describe the results in sentence and you type inferential statistics results like this. So within the parenthesis, you enter the degrees of freedom. So this score, 7.56, is t-score, separated by comma and p-value. Okay, so you can just use this format when you write up the results section. So what if the p-value is greater than the alpha? That means you fail to reject the null hypothesis. Therefore, it is not statistically significant and you cannot support your research question, a research hypothesis. One last additional information about an independent t-test is the p-value does not tell you any information about how much the two groups are different. Okay, so p-value 0.01 doesn't mean it's better than 0.04. Okay, it's just a probability differences. It doesn't tell you how much two groups are different. This magnitude of difference between groups is quantified as the effect size. Some typical value that is used in science is Cohen's d or Hedges g. So ideally speaking, when you report the statistical results, you should report the t-score, p-value, and the effect size.